In our previous lesson, we implemented authentication for our REST API using a JSON Web Token. The users of our system send a credentials pair to the API to obtain a JSON Web Token that they can then use to authenticate their API requests. However, access tokens should be short-lived for security reasons, and that is why we introduce refresh tokens. So let's see what they are. We use refresh tokens to mitigate the fact that access tokens have a short lifetime, typically a couple of minutes. A refresh token may have a much longer lifetime than an access token. The client application can send a refresh token to our API to do a so-called refresh of the access token. We will validate if the refresh token is valid, and if it is, we will return a new access token and a refresh token pair. From a security perspective, anyone could send a refresh token to our API and get back a new access token and a refresh token. So this is why we implement support for refresh token rotation, where we always return a new refresh token whenever we successfully validate it and generate a new access token. This can be useful if a malicious user steals a refresh token, which they can then send to obtain a new access token and a refresh token pair. What we can do is track the refresh token's history. For example, let's say we have an original refresh token that we send to obtain back a new refresh token. We can keep track of all of the refresh tokens that were used historically and create a so-called chain of refresh tokens. And whenever we see an older refresh token being used in our API, that's going to trigger an invalidation of the entire chain and force the user to re-authenticate because it may indicate a malicious user obtained the refresh token. As part of this lesson, we won't implement this advanced version of refresh token rotation. We'll just keep it simple and always return a new refresh token whenever we successfully validate it. In our example, this is what the flow will look like. The client application can send some request to our REST API, and let's say that the access token is expired and we return back a 401 unauthorized response. The client can then automatically attempt a refresh token flow where they send a request with the refresh token in the request body to the auth refresh endpoint. And then we have two alternatives. Either this is a valid refresh token, in which case the REST API will return a new access token and a new refresh token, and the client can then retry the original request with a new access token, and we can expect that they will get back a successful result. Or the refresh token could be invalid or expired, in which case we return 401 unauthorized and we force the user to authenticate again. So let's go into our code and see how we can implement support for refresh tokens. I will start by creating an entity that we can use to represent a refresh token. So inside of the entities folder, let me create a refresh token class. And then here's what the implementation of this class will look like. I'll assign an identifier just as a database primary key for this refresh token, and we'll have a reference to the user identifier, the token value, and when this token expires. I also added a navigation property to the identity user type, and this is because I want to use refresh tokens as part of my identity database context. So now I want to configure this type with my database context. In the database folder, I will open up the application database context class, and I'm just going to configure my entity inline right here. I will say builder entity refresh token, and then here's the configuration that I want to use for the refresh token. I'll configure the ID as the primary key. I'll set the max length for the user ID and the token properties. The token has to be a unique value inside of the refresh tokens table. This way we prevent two different users having the same refresh token. This is a huge security concern, so this helps us solve this problem. And I'm also adding a reference to the navigation property for the identity user, where the identity user may have multiple refresh tokens. I'm setting the foreign key, and I'm also including cascade on delete if the user is removed for some reason. Now let's include a database set for our new entity type. I'll say database set refresh token, and let's name this refresh tokens. The next thing I need to do is create a respective database migration. So let me open up the package manager console, and I will say add migration, add refresh tokens. This is the name of the migration. The context will be the application identity database context, and the output will be in the migrations identity folder. Here is the generated migration. This will create our database table where we can store our refresh tokens. So let me close this down. This migration will be applied when I start the application, and I can also close down my database context and the refresh token. The next thing we need to do is to update the token provider in the services folder to generate a refresh token value. And there aren't any special requirements here. Here's the implementation that I will use. I'll use the random number generator to generate 32 random bytes, and then I will encode them in a base 64 string that I will return as the refresh token. We can even make this method static now because it's not accessing any instance data. That's it for the token provider. I can also close down the services, and let's head into the auth controller where we have to make a couple of updates. Let's start from the register endpoint, and in this response here, we have our refresh token. Now I will move this before committing the transaction because we need to store our refresh token in the database, and this has to happen in the same transaction. So let me initialize the refresh token, and we have to set a couple of these variables. Let's, for example, use a version 7 UUID as the primary key. Then I will set the user ID using the identity user ID property. The token value will come from the access tokens DTO, where I have a refresh token property. And the expiration time, we're going to calculate this based on the current time. And I'm going to add the number of days using the JWT auth options, which I don't currently have, so I need to inject another service. I will inject the iOptions interface, specify JWT auth options, and then let's define a private read-only field to hold this variable that I will call JWT auth options. Now that we have this, I can go ahead and finish this implementation here by saying JWT auth options refresh token expiration in days. Then I need to add this to my identity database context by saying identity-db context refresh tokens, and we add the refresh token, and I need to say await identity-db context save changes async. So we are persisting the refresh token when we register our user, and this has to happen in the same transaction. Now I will also need to do this when logging in the user, so let's go to the login endpoint and implement the same functionality. And finally, I can implement my new endpoint, which is the refresh token endpoint. It's going to be HTTP post. The route will be refresh, and then it will be a public async method returning a task. The response will be an action result returning the access tokens DTO, and let's call it refresh. In the auth folder where we have our DTOs, let's create our refresh token DTO, and all we need here is our refresh token value. It will be a required string, and now I can use this in my new endpoint. Let me close this down. And here I will specify the refresh token DTO. And then here's how we are going to implement this. We need to get a refresh token, and I can use the identity database context to access the refresh tokens table. Now I will need to include the user navigation property, and I want to get back the first refresh token that has the same value as the one that is specified in our request. Now if the refresh token is null, then we can just return an unauthorized response. This will return the 401 status code. Next, we also need to check if the expiration time of this refresh token is valid. And if this is the case, we can also return an unauthorized response. If we manage to get past both of these checks, then I need to create a new access token and a new refresh token. So I will copy what I had above, and I need to provide the identity user instance. Now I have this on my refresh token, so now I can pass in the user ID and the email, and I get back an access tokens DTO. Here is where we can implement our token rotation by updating the token property, and I can also update when this token expires. So this will be datetime UTC now, add days, and I'll specify the refresh token expiration in days. Finally, I can call my identity DB context and call save changes to persist this before returning the access tokens DTO. In this implementation, I'm overriding the value of the existing access token. So this is one way to implement refresh token rotation. An alternative could be creating a chain of refresh tokens where we keep track of the parent token for each new refresh token, and this can allow us to implement a more robust solution. Now let me start the application. This will also apply my database migration, and I can test out if this is working as expected. Let's first send a post request to the login endpoint where we will attempt to authenticate. We get back an access token, the same as before, but now our response also includes a refresh token. We can use this refresh token in the refresh token request, which I also have as part of this Postman collection. And if I replace the value here and send this request, I will get back a new access token with an updated expiration time and a new refresh token that I can again exchange for an access token once it expires. Now let me send the same request with the old refresh token, and you will see that we're getting back a 401 unauthorized response because the old refresh token is no longer valid. And if I specify the new refresh token and send this request, we get back a new access token and refresh token pair. So that's it for our quick refresh tokens implementation in the DevHabit RESTful API. In our next lesson, we will start talking about authorization by properly protecting our resources, and we will implement owner authorization.